Adding with algebra graphically. So the last lesson we looked at using algebra tiles to represent graphically an algebraic expression. So we're going to use that concept today to take a look at how we can add more than one algebraic expression. So let's start by reviewing how to express an algebraic expression as a graphical model. So remember that the x squareds are the large squares, and I want to make sure that my negative ones are colored in and my positive ones are left blank. So for this one, I have negative 2x squareds. So I draw two large squares that are shaded in to represent the negatives. I have 1x. So I'm drawing a rectangle that is not filled in to represent a positive x. And I'm drawing three smaller shaded in squares to represent negative 3. So now I have negative 2x squared plus x minus 3. The next algebraic expression is x squared. That's a positive x squared. So I'm drawing a large square. I have 3x, so those are positive 3x's. So I'm drawing 3 rectangles. And I have negative 2, so I'm drawing 2 small squares shaded in. We're going to take a look at some terminology, so it's important to know some definitions as we progress throughout this unit. So we're going to take a look at using some values and some terms to express our expressions in a mathematical way. So what you need to know first of all is that a polynomial is an expression formed by combining terms with addition or subtraction signs. So a polynomial is any type of algebraic expression. When that algebraic expression only has one term, we call that a monomial. So think about a monocle. So that one single glass that some people wear, a monocle, a monomial is one term. The next term that you need to know is binomial. A binomial is an algebraic expression that has two terms. Think bicycle, 2 wheels, binomial. Trinomial is an expression that contains 3 terms. Think tricycle or triangle, 3 sides, 3 terms. And the last definition that you need to know, we're going to take a look at a lot, is like terms. And like terms are terms that have the exact same variables with the exact same exponents. So when we're looking at this graphically, visually, we want to look at like terms having the same shape. So they are either both large squares, both rectangles, or both small squares. So we're going to create graphical representations for each of the expressions below, and we're going to use that graphical expression to write a simplified expression for the graphical representation, and then we're going to classify the polynomial as either a monomial, a binomial, or a trinomial. So first of all, I want to look at first drawing the shape. So my first algebraic expression is 2x plus 3x. So I'm going to start by drawing 2 rectangles. Those are positive, and I have 3x, so 3 rectangles, and those again are positive values. So my graphical representation shows that I have 1, 2, 3, 4, 5 x's, so that's my simplified algebraic expression. And because it only has one term, this becomes a monomial. The next expression that I have is 3x squared minus 4x squared. So now I want to draw 3 large squares. These are positive values, so they are not shaded in. Then I'm drawing 4 large squares that are shaded in to represent negative 4x. So if you think back to when we looked at expressing integers visually, so positive and negative integers, we can do the same thing here when we represent algebra tiles visually. So when we have one of each, so if we have one positive and one negative, those will cancel each other out so that those two then become 0. And I can do that for as many sets of the same shape that I have. So you can see that when I cross out my pairs, I'm left with just one large rectangle or one large square. So I have negative x squared as my simplified algebraic expression. This is only one term, so it becomes a monomial. My next algebraic expression is 2x minus 3 minus 5x plus 4. So I'm going to start by drawing my two x's, so two rectangles. Those are positive. Then I have negative 3, so I'm drawing 3 small squares that are shaded in because they're negative. I have negative 5x, so I'm drawing 5 rectangles shaded in. And I'm drawing 4 small squares to represent my positive 4. So again, I want to eliminate any of the shapes that are the same size, but one positive and one negative. So I'm going to cancel out my two sets of the x's, and I'm going to cancel out three sets of my numbers. So what I'm left with is 1, 2, 3 negative x's and one positive constant or one positive number. This expression has two terms. So it has two terms separated by an addition sign. So because it's two terms, I write that as a binomial. My next expression is 3x squared. So I'm drawing 3 large squares. Those are positives. Plus 2x, so 2 rectangles. Again, those are positive. Minus x squared, so 1 large square but shaded in. And positive 4, so 4 small squares. Again, I want to eliminate any set of shapes that are the same size, but one's positive and one's negative. So I am eliminating one set of my large x squareds. So I'm left with 2x squareds, those are positives, plus 2x plus 4. This has 3 terms, so this is a trinomial. So we consider terms with the exact same shape to be like terms. And we use that terminology and that strategy to simplify those algebraic expressions. So let's do a couple of more examples. This time you'll notice that our algebraic expressions are separated by each other using brackets. The same strategy we're going to apply for these ones. So we're going to express each individual term as a graphical shape, and then we're going to eliminate any set of positive and negatives, and then write our simplified expression. So I have x squared, so 1 large x, 2x, so 2 rectangles, and 1 small square to represent my positive 1. Then I have positive x squared, or x squared, plus x, plus 3. I don't have any negatives in this expression, so I can just go ahead and count how many squares, how many rectangles, and how many small squares I have. So I have 2 large squares, so that's 2x squared. I have 1, 2, 3 rectangles, so that's 3x. And I have 1, 2, 3, 4 small squares, so that's positive 4. The next example, I have 2x squared. Those are positives, and those are large squares. I have plus x, so 1 rectangle, and minus 3, so 3 small shaded in squares. The next expression I have in this one is 2x, so I have 2 rectangles, minus 3x squared, so I have 3 large squares that are shaded in, and I have negative 1, so 1 small square shaded in. The only set of shapes that I have that are positive and negatives are my x squareds. So I'm going to eliminate 1 set and then 2 sets. So the only large square that I'm left with is a negative 1. So I'm going to start with my negative x squared. So I always want to start with the largest shape that I have and then work my way down to the smaller shapes. So I have negative x squared. I have 1, 2, 3 positive x's, so plus 3x, and I have 1, 2, 3, 4 negatives, or negative 4. So my simplified expression is negative x squared plus 3x minus 4. And the last example that we're going to look at is 3x squared. So I'm drawing 3 large I want to draw 3 large squares. And those are positive squares, so I'm not going to shade those in. I have negative 5, so 5 small squares shaded in. The next part of my expression is 4x, so I have 4 rectangles. And negative 2x squared, so 2 large squares shaded in. So I'm going to start with my large squares. I have 2 sets of positive and negatives. So I cancel those ones out and I left with 1 x squared, which is positive. My rectangles, I have 1, 2, 3, 4 of those, so plus 4x. And my little small squares, I have negative 5 of those, or 5 negatives. So my simplified expression is x squared plus 4x minus 5.